Electromagnetism explains how electricity and magnetism are closely connected and why many modern devices around us are able to function. In our daily life, we use electromagnetism without even realizing it, such as when charging our phone, switching on electric fans, watching television, or listening to music through speakers and earphones. All these devices depend on the interaction between electric currents and magnetic field to operate efficiently. For example, electric currents create magnetic effect that allow motors to rotate, fan to spin, and speaker to produce sound. Beyond household devices, electromagnetism is also essential in transportation system, medical equipment, and communication technology. Although we cannot see electric and magnetic field, but they work continuously in the background, making our life more comfortable and convenient. By linking electromagnetism to common, everyday experiences, we can understand that this topic is not complicated or frightening, but practical, important, and extremely useful in modern society.
Okay, so now let's understand the core idea of electromagnetism. At first, electricity and magnetism were thought to be two different things, but actually they are closely connected. First, electricity. Electricity happens when charges move. These charges create something called an electric field. You cannot see it, but it exists around charged objects, and it is what causes electric forces. Now, magnetism. Magnetism appears when charges are moving. In other words, when an electric current flows, it creates a magnetic field around it. So every wire that carries current actually behaves like a magnet. If you look at the diagram, you can see that when current flows through a straight wire, circular magnetic field lines form around the wire. This shows that electricity directly produces magnetism. So, the main idea here is very simple. Electric charges create electric fields and moving charges create magnetic fields. Because of this, electricity and magnetism are not separate forces. There are two sides of same force, which we call electromagnetism. Understanding this connection can help us explain how many devices work, such as motors, generators, and even our phone chargers. So before going into examples and applications, this is the key concept that you should remember. When electricity moves, magnetism appears.
Electromagnetism works through clear cause and effect relationships. When an electric current flows through a wire, it produces a magnetic field around it, showing how electricity can create magnetism. The direction of this magnetic field can be shown using the right-hand rule, where the thumb points in the direction of the current and the curled fingers show the direction of the magnetic field. This relationship also works in reverse. When a magnetic field changes, such as when a magnet moves near a coil of wire, it can induce an electric current in the wire. This process is known as electromagnetic induction and is the principle behind many devices like generators and transformers. The key idea here is not memorization, but understanding the cause and effect relationship, which is current creates magnetic fields and changing magnetic fields can create electric currents.
Now I will explain one clear experiment, which is electromagnetic induction. This experiment used three main components: a magnet, a coil of wire, and a sensitive emitter. First, when the magnet is moved toward the coil, the magnetic field around the coil changes. Because the magnetic field is changing, an electric current is induced in the coil. This induced current can be detected by the emitter. If the magnet is not moving, there is no induced current. Therefore, a changing magnetic field is needed to produce electricity. This principle is called electromagnetic induction, and it is used in electric generators in power stations.
Now, you might be wondering how electromagnetism is applied in real life, whether we actually see or use it. One clear example is the maglev train in Japan. Unlike conventional trains that use wheels, maglev trains rely on electromagnetic levitation to lift the trains above the tracks. Powerful electromagnets on the train and guideway create magnetic forces that eliminate contact with the rail, greatly reducing friction. This allows the train to travel at extremely high speeds, reaching over 600 km per hour. Electromagnets are also used for guidance and stability, while linear motors propel the train forward using a moving magnetic field. Another important application of electromagnetism is found in wind turbines. Wind energy turns the turbine blades, which rotate a generator. Inside the generator, magnets and coils of wire interact, producing a changing magnetic field that induces an electric current. This process, known as electromagnetic induction, enables wind turbines to convert renewable wind energy into electrical energy for everyday use. Electromagnetism is also essential in medical technology, particularly in MRI scanners. MRI machines use very strong magnetic fields and radio frequency electromagnetic waves to produce detailed images of internal organs and tissues. Unlike X-rays, MRI does not use ionizing radiation, making it a safer method for medical diagnosis. Alright, that concludes our presentation on electromagnetism. We hope our explanation clear and give a better understanding of how important electromagnetism is in our life. Thank you for listening.